Okay, graphs and transformations. So we're going to be looking at how to sketch cubics and reciprocal graphs. We're going to be able to look at points of intersections between two graphs and transform graphs. Okay, nice and simple. Okay then, so cubic graphs will be something completely new to you. Okay. Quartic graphs is like cubic graphs has the highest power of x is 3. Quartic graphs, the highest power of x is 4. Reciprocal graphs, which is, again, it is new, but we would have seen, for example, a over x in the GCSE sometimes, in the IGCSE. It might just ask us to draw it by filling in a table. Points of intersection. Now, we have done points of intersection before, mainly with a y equals mx plus c and a quadratic. So a straight line and a quadratic, we find the points of intersection using either simultaneous equations or the graph. We're going to be finding points of intersection, but it won't just be with, it could be with another graph, but it could just be the x-axis, to find out where the solutions are, the roots. And then transformations of graphs. Now, we have done this in the IGCSE, okay? So really, it's just transforming, instead of the standard quadratic and trig graphs that we know how to transform, it will be transforming different types of graphs. Okay then, so when we're talking about the highest power, we actually call it an order, okay? So the order of a polynomial is its highest power. So the order of 1 is going to be, for example, a straight line, isn't it? Y equals mx plus c. The highest power is x to the power of 1. Okay? The order of a polynomial with 2, that's going to be a quadratic. So that's going to be an x squared plus bx plus c. Okay, this is a quadratic. Okay, order 3, our highest power is going to be a cube, which we know is called a cubic. Okay, we've just discussed this, so everyone should be able to answer. Order 4, the highest power is to the power of 4, which is called a quartic. And to the power of 5, does anybody know what that's called? I have no idea, so if anyone Googles it and finds out, you get a house point. Done, Sarah. It's a quantic. Absolutely amazing. No E. Great. Okay, polynomial graphs. Now, believe it or not, if we have an order 2, okay, when we cross the x-axis, if we cross it, normally we would cross it twice. Right. We have a polynomial, then, if we were to cross the x-axis, what would be the maximum amount of times we could cross it? Cubic. 3 times. If we had a cubic, the maximum amount would be 3 times. 1, 2, 3. It doesn't necessarily mean it will cross 3 times, but the maximum amount of times is 3. Perfect. And then obviously with a quartic to the power of 4, the maximum amount of times would be 4. Okay? It's quite nice really, isn't it? So that would be the maximum number of solutions. So, here we go. What we're going to take a look at is what is actually going to happen, right, as x tends to infinity. So, for example, whenever we say a quadratic, we know it looks like a U if it's a positive. And as x tends to, this is if it's negative. A is greater than 0 is a positive. A is less than 0 is negative. We know it gives us what shape? An N. So very quickly, you are going to, for me, find out what happens when we have a positive A. And you know what app we're going to use. It's my favourite app of all time. Desmos. I want you to have a play around. Can you put y equals ax cubed plus bx squared plus cx plus d? And then you can add sliders. I'll show you how to do that now. So, with a positive ax cubed, what's going to happen? It's going to start in the bottom left and finish in the top right. Before you change this on your slider, let's predict what will happen if we have a negative ax cubed. Okay, if we have a negative ax cubed, where's it going to start? Okay, someone said top right, someone said top left, bottom right, bottom left. Let's have a look. So here it starts in the bottom left if it's a positive polynomial, cubic. If it's a negative, it starts in the top left. Okay? Okay, what happens if we have to the power of 4? Can you quickly investigate that, please? To the power of 4. Yeah, so what's going to happen is, well done, Giovanna. It's going to cross 4 times. It's going to look like this. Okay? And if it's a negative, what's it going to be?
Top, bottom left and bottom right.
Oh.
This doesn't have to cross.
There we go. No, it doesn't. You're right. Okay. So, if a is greater than 0, okay, we know what's going to happen. We're going to focus on cubics today. Okay, so here is what actually happens to the graphs, because sometimes my drawings aren't amazing. Okay then, so here we go. So, step 1. We are going to look at how to sketch these curves. What I want you to do is we're going to be using Desmos today to help us understand if our answer is correct or not. So we're going to sketch first, then use Desmos to check. I'm going to show you how it goes. Here we go. Now, step 1, we need to know the shape. To find out the shape, we need to know, is it a positive x cubed or a negative x cubed? We know a positive x cubed, okay, starts in where? Bottom left. So it's going to look like this. We know that a negative x cubed starts in the top left. So it's going to look like this, okay? So basically, it's either going to be an N, a capital N, or a lowercase u. Okay? Good. Right then. So, step 1. Is it a positive or negative? That's what we look for. I have a positive x times a negative x times a positive x. What does that tell me? It is going to be negative. So I have a negative x cubed. It means my shape is going to look like this. Okay? So I did that because I look at all of the x's I have available. I have a positive, a negative, a positive. Positive times a negative times a positive is a negative. Yeah? Perfect. My roots. Now it's easy when they factorise it, because what are my roots here? My root here is going to be 2. Here it's going to be 1, because it's already got a negative x. Remember, it's what makes this bracket 0. 1 minus x has to equal 0. So 1 minus x equals 0. If I move the x to the other side, I get 1 equals x. Okay, please do not just, okay, we're in A-level. We do not just do the opposite of the bracket. We understand why this equals 0 is because where the y-axis, where the y-coordinate is 0. That's where we're going to find our roots, when y equals 0. And then the next one is going to be minus 1. Now, so the shape we did by multiplying to get x cubed. My y-intercept, okay, is nice and easy. Oops. Is I'm going to do minus 2 times by 1 times by 1, which gives me minus 2. So my y-intercept is minus 2, okay? Y equals minus 2. So my final sketch, the moment we've all been waiting for, okay, which is my favourite part. Let me just colour this in white so we've got a nice sketch going on. Okay. Here we go. So step 1, we draw our axes. We write x and y, don't we, Najib? Okay, now our roots are 2, 1 and minus 1. So what I'm going to do, everyone, I'm then going to delete. But this is what my process is in my head, so please don't copy what I'm about to write. If I've got 2, 1 and minus 1, I know I've got 2, 1, minus 1, yeah? But, so I know I've got 2 points on one side, 1 point on the other. But guess what? Okay? I'm not going to put the points in and then draw my graph. No, I just know that I need to do it this way. So I'm going to delete these points because I find it harder to do. And now I'm going to do this. I know it's got to cross the right-hand side twice, so look. Woohoo! Now I know this is 2, this is 1, this is minus 1, and this point is minus 2. Now, please make sure we are using coordinates for these. Because if I was going to do this, and if I was to put 1, 2, 1, and then estimate that that was minus 2, okay, my drawing's not that good yet. I have been practicing, but if I was to do that, it'd end up, I mean, look at that. That's ridiculous. I'm trying to connect the dots by using curves, and my brain doesn't attach that way yet. So I am going to get better at that, but this is why I said to you, I know I'm going to have to it's going to have to cross 2 here. If I don't put dots in, then the dots can go where it crosses. I'm not connecting dots, am I? Okay, and then my drawing, this drawing, I'm going to give it a 9.5 out of 10 realistically. Okay? This, on the other hand, minus 7 out of 10. Okay, step 1, what is the shape? Now, we're either going to have a positive x cubed or a negative x cubed. Okay, so to find that out, I'm going to multiply all of my x's. I'm going to get x squared times x, which is in fact positive. So my shape is going to look like this. Okay, it's a positive x cubed. Now my roots. Okay, so here we go. We have, when does either side equal 0? So I've got x squared bracket x minus 1. When does x minus 1 equal 0? When x equals 1. And when does x squared equal 0? When x equals 0. Now in this case, I've only got 2 roots. Okay, so I'll show you what happens with the 2 roots. But here, this is a positive x squared. Are we happy it's a positive x squared? We know an x squared is a u, so I'm going to show you what happens. So then, what's going to happen is the y-intercept. Now, if we have a look for the y-intercept, if you think about it, okay, when we have 3 brackets together, you know all the numbers are going to be multiplied together. When I have just one bracket and something on the outside, if I multiply x squared times x, get x cubed, x squared times minus 1, I'm going to get minus x squared. So actually, my y-intercept is in fact 0, because there is no y-intercept. So y equals 0. Okay, so now what's going to happen? We're going to get our sketch ready. Okay. So, step 1. We draw our axes. X, Y. Really, we should use a ruler for this. Okay? Right then. So, right. With the x plus 1, it's going to have to cross through that. So it's going to look like that. Yeah. Okay, this is going to be 1, 0, and this is going to be 0, 0. Okay. Perfect. Oh God. So then, let's have a look. To find the shape, we need to know, is it positive or negative? We have a negative x times a positive x squared, okay? So that actually means I've got negative x times x squared, which is negative x cubed. So I know it's a negative shape, so it's going to look like that. Then my roots is, when does each bracket equal 0? So for 2 minus x, that means x equals 2. And x plus 1 squared, this is equal roots. X equals minus 1. Okay? Then my y-intercept is 2 multiplied by 1 squared. 2 times 1 squared, which is 2. So now when I sketch my graph, x and y, I know it's going to cross at 2, minus 1, and 2. But because this minus 1 is a repeated root, okay, it's just going to touch it. So we only have 2 solutions. So it's going to touch it. There we go. So this is going to be, so this is why I don't like drawing the dots, because now I'm going to get minus 1, 0. This is 2, 0. This is 0, 2. So it only crosses twice. We should all be happy with that for the first question. Now the second question. Now this one's always a funny one. Okay, so step 1, what shape is it? Okay, well it's positive x cubed. So the shape is going to be like this. My roots is when x minus 4 equals 0, so x equals 4. My y-intercept is minus 4 cubed, which is minus 64. Now, these types of graphs are a bit more difficult because it has one repeated root. Okay, so this has one solution and the solution is at 4, roughly here. And let's say this is minus 64, okay? So, okay, my drawing's not great. It's going to look something like this. There we go. Okay, that's because, if you think, you see this little, like, hump here and this little hump here? This would normally be dragged down and this one would normally be dragged up. Okay, but it's not. So this is how we draw the graph, and we have to write in 0 minus 64, and this is going to be 4, 0. Okay? But obviously, once you've drawn drawn a few graphs, then you get to understand what's going on, don't you? So then, cubics with limited roots. So in this case, sometimes part of the graph might not even cross the x-axis. Okay? So the shape, is it a positive or a negative? Well, if I multiply this x by x squared, I get a positive. So I know it's going to be like this. My roots here, x plus 1, x equals minus 1. If you put x squared plus x plus 1 into your calculator, what happens when you solve it using the equation solver? You should find we get an I. I'm pretty sure we get I's. Yeah. We cannot solve this. If we cannot solve a quadratic, what we have to do is complete the square. So we're going to get x plus 1 squared minus 1 squared plus 1. So, absolutely. So, then we're going to get minus 1 squared, which is 1 over 4. So then I'm going to get x plus a half squared plus 3/4. So that means my minimum point is minus a half and 3/4. Okay? And it's a minimum because it's a positive quadratic. So we have a minimum point, we have one solution, and our y-intercept is going to be 1 because the constant's multiplied by the constant. So our final sketch is going to look like this. Are we ready? Here we go. So we have our x, we have our y. So how it's going to look is we know it's going to cross at minus 1. It's going to cross again at 1. Okay, and then it's not going to have any roots. So it's going to look like this. So we're going to get so it's going to go up, down, up. Okay, the reason why it's done that is because this minimum point is minus a half 3/4. So I'm going to draw it again here because I did say to you, sometimes my sketches are awful. So now I know what the shape looks like, I can draw this really nicely. There we go. Okay, so this is a better graph. So this is now going to be, so sometimes if you want, just draw it twice like I do. Draw it once to know what's going on. So this is going to be minus 1, 0. This minimum point is minus a half 3/4. And then where it crosses the y-intercept is 0, 1. Okay? And if you put this on Desmos, you're going to get the same graph. Good question, Kate. So this one, I can solve x plus 1 equals 0. I solve this and I get x minus 1. So I know that the curve has to cross at minus 1 because I can solve it. When I try to solve x squared plus x plus 1 equals 0, okay, so when I try to solve this, okay, if I try to factorise, I can't, and if I put it into the quadratic formula, I get an error, or in some of the new calculators are giving you imaginary numbers. That means it's not solvable. That means it never crosses the x-axis. There are no roots. Okay? So if it has no roots, the only thing we can do is we need to complete the square to find the minimum point. And this is our minimum point. So essentially, we know it's going to cross at minus 1 because that is a solution. Our minimum point is going to be here, and it's going to cross the y-intercept at 1. So we've got 3 points, and our graph needs to look like this. We know that this one isn't going to touch the x-axis, okay? So we just have to kind of put it together. Okay, so sometimes it says, write down the actual, here's a graph, write down what the equation is. Now this one's really easy. Step 1, we're just going to do the reverse. Is it a positive or a negative? Positive, because it goes like this. So we know we're going to have a positive x cubed. So if I want to, I know it's positive. The second thing I look at, how many roots are there? I have 1, 2. So this means I have a repeated root because this is the minimum. So I have a repeated root. So I know I'm going to have 2 brackets then. And one of the brackets is going to be a squared because it's a repeated root. Okay? Because the reason why I know it's repeated is because it makes a, what? U. Okay, so I know it's going to be a quadratic. So then, if one of my roots is minus 1, 0, I know I'm going to have x plus 1 as a definite root. Okay? Then, because I have repeated roots, this is going to be, I know it's positive 2, so this is x minus 2. Okay, now that I've done that, I can double check. I can A, draw the graph to double check I'm correct. but B, I will need to expand it out. So if I double check, I've got x times, and if I just write it out like this, x plus 1, x minus 2, x minus 2. Now if I think about it, x times x times x is positive x cubed, so I know my graph looks like an n. Check. I have one root which is minus 1, check, and I have two roots which are equal because they're both 2. Now, all it does is it touches 2. If it touches 2, it means it's an equal root. Check. Okay? Great. And then 1 times minus 2 is minus 2 times minus 2 is positive 4, which is my y-intercept. Check. I know I'm right. Okay? Now what I've got to do is expand it out. So I'm going to get x times x is x squared plus x minus 2x minus 2, which is x squared minus x minus 2, all multiplied by x minus 2. Okay? So then I'm going to multiply everything by x to get x cubed minus x squared minus 2x. I'm going to multiply everything by negative 2. Negative 2x squared plus 2x plus 4. I'm going to simplify, so I'm going to get x cubed minus 3x squared plus 0x plus 4. So that is the actual answer. So in this case, our A equals minus 3, and our B equals 0, and our C equals 4. Because the B is the coefficient of the x, isn't it? And we don't have a coefficient of x, so it must be 0. Okay? So really good point. If the minimum or the maximum touches the x-axis, it means it's an equal root. If the minimum or the maximum do not cross the x-axis, there are no solutions. Okay, and we will have to complete the square. Okay, so for the first one, we're going to have a positive quadratic. Okay, and it's going to cross at 0, and it's going to have a double root at 3. Does it look like this? Perfect. And this is 0, 0, and this is 3, 0. Okay, perfect. Question 2, a negative, right, the negative is not inside the bracket. So essentially you have to cube the bracket first, okay, and then apply a negative to everything. So we're going to have our x and our y coordinate. It's going to cross at negative 8, okay, and it's a negative cubic, and it's a repeated root. So it's in fact, it's not going to be an n, it's going to be like a u. So it's going to be like repeated root minus 2. Okay, and it's going to cross at minus 8. It's going to look like this, I think. Oh. It's the weight there. Ah! Right, this is why I can't draw the points. Forget I drew the points, okay? There we go. So this is going to cross at 0, minus 8. And here this is minus 2, 0. Now, again, this is why sometimes I don't draw the points. Because as you can see, when I try to draw it, it doesn't make sense. So as long as you write the coordinates, it doesn't matter. The next question, a curve has this shape, touches the x-axis at 3 and crosses the x-axis at minus 2. Okay, so if it touches the x-axis at 3 and crosses at minus 2, it's going to be, like this. No? Oh, sorry. I've read that's the y-axis. A curve has this shape. Touches the x-axis at 3 and crosses the x-axis at negative 2. There we go. Okay. Oh, yeah, it already shows it. Honestly. So this is then going to be x plus 2 x minus 3 squared. Okay? Then the last one. Oh my golly. Okay, this is a challenge. It's 3, 4, 5. To the power of 5? It should be to the power of 5. Okay? Did anyone get to the power of 5? Because if you look, x squared times x is x cubed, and this x is an x cubed. It is 6. Oh my. X to the power of 6. Okay, so we'll double check that. You can try that later if you're feeling brave. Okay, so if we just have here x minus a is to the power of 1, yeah? When we have x equals a, it's just going to, this is our y, this is our x. I'll just do them for all of them. X, y, x, y. Okay, then what's going to happen if we just have x minus a to the power of 1? It's just going to cross once on the x-axis. Okay? If we have, the next one is x equals b, and this is a squared. What happened there? Oh, there we go. If we have x minus b, and it's in brackets squared, it's going to touch... Oh. It's going to touch the x-axis. Okay? If, part C, we have x minus a number cubed, okay, this is not a repeated root. It is a repeated root, but it's repeated 3 times, isn't it? This is the one that's going to look like, can you see it's not quite a straight line? It's a bit like this. And this is like a triple equal root.
It's like when you put a straw in water.
Yeah, when you put a straw in water and you start to bend it. Absolutely amazing. Great analogy. Okay then, so here we have, we're going to learn how to draw a, it's not a quadratic, is it? What's it called? Okay, quartics. Are we ready? So, if it's a positive, so let's think about this, okay? So, if we look at all the x's, we've got x positive times x positive times x positive times x positive. We know, what do we know? Is a positive x to the power of 4, so it's going to be a w, essentially. Yeah? But it's like a bit of a weird w. Our roots, we're going to have 4 roots. We're going to have 0, x equals 0, x equals minus 1, x equals 2, and x equals 3. Okay, everyone should be happy with just finding the roots and everything. Then our y-intercept, we multiply all the numbers together, okay? So we're going to get 1, minus 2, minus 3, but then don't forget, you see this x on the outside? It's a 0. Okay? So actually our y-intercept equals 0. Okay, now Kate has decided to make her life easier. Every time she sees an x, she's going to put an x plus 0. That's completely okay if that makes it easier for you. Okay? So, here we have x, y. It's going to be a w. Now again, is everyone happy? I am just going to draw the points and then I'm going to delete them so we know a bit what's going on, yeah? So, we know it's going to cross at minus 1, which is 1 point on this side. We know it's going to cross at 0, which is here. Then we know it's going to cross at 2 and then 3. So, my w, okay, I might be able to get it in the points. Let's see. Voila!
Magic.
Absolutely, thank you, Faris. So then, here we go. We have minus 1, 0, We have 0, 0. This point is 2, 0 and 3, 0. Fantastic. Again, you can always check on Desmos. Okay, so the next one, let's have a look at what's going on. Okay, so I'm going to do what Kate does because I actually like this method. X minus 2, x minus 2, x plus 1, x minus 3. Okay, so let's have a look at our positive, not our positive, let's have a look at our shape. Positive x, positive times a positive is a positive, times a positive is a positive. Oh, I've written the last question wrong. Wait there. This is, 3 minus x, okay. So, positive times a negative. So what shape is it? An M. Negative x to the power of 4, which is going to look like a weird M. Okay? Then, let's multiply all of our, our roots. So we have a repeated root at 2. Okay, because we've got 2 twice. So we're going to have x equals 2, x equals 2. I'm going to write that down because we know if there's a repeated root, it's going to touch, isn't it? Then we have x equals minus 1, and then we're going to have x equals 3. Okay, because I've solved all the brackets equal to 0. Everyone happy? Y-intercept. Okay, I'm going to multiply all the numbers together. Minus 2 times minus 2 is 4, times 1 is 4, times 3 is 12. So y equals 12. Okay, now here we go. So this is x, this is y. Okay, I'm going to put my points down. Okay, now let's hope, I wonder if I can do it again. This one is minus 1. This number 2 is a repeated root. So it's going to be touching. I need to remember that. This is 3, and this is 12. Okay? But also, it's going to be an M. Absolutely, it's negative 12. So it's going to be down here. Okay, because, you know. Right, so we're going to start here. We're going to go up. We're going to come down. It's going to touch because it's an equal root and back round. So then, this one is going to be minus 1, 0. This is going to be 0, 12. 12. This one is my equal root. So this is 2, 0. Okay, so it just touches. And remember, I had 2 of those up here. And then this last one is 3, 0. Perfect. Right, for this one, if you want to go ahead and draw your own one, go for it. If you want to stick with me, stick with me. I don't mind. Right, so here we go. We have, we're going to draw our graph, x and y. Now, here we go. If we have a look at this one, we have to apply our knowledge of what we know. So first of all, positive cubed times this is a positive. So we know we have a positive x to the power of 4, so it's a w. Oops. It's a w. Yep. Then, minus 1 cubed is minus 1 times 1. So we know the y-intercept is at minus 1. And then, if we solve it, we have a normal root of x equals minus 1, which is going to be here. And then here, we have x equals 1. This is a repeated root 3 times. Okay? So, this is how I think it looks, right? And then we're going to check on Desmos. Are we ready? So, using my knowledge, here we go. So, it's got to be a W. So, I think it's going to look like this. Wait. Okay. Whew. It would look like this because, right? if you think about it, when we have an x cubed and all of its repeated root, it looks like that bit, doesn't it? Okay, and it kind of makes a W if there's that little hill. Like, right, someone check on Desmos, am I right? But it makes logical sense, right? From all that we've learned this lesson, this makes the most sense. Because if we write everything down, we've got our root at -1, 0. It crosses the y-axis at 0, -1. And then I've got my, this is my triple root at 1, 0. So I've got all the coordinates I need. Okay then, so well done, that is completely correct. Well done to me, actually. Okay then, next question. Oh, sorry. Okay then, so next, sketch the curve with the equation x minus 2 cubed. Right, to the power of 4. X to the power of 4 is positive, yeah? So I'm going to have a W. Right. Minus 2 to the power of 4 is positive 16. So my y-intercept is 16. And I have equal roots of x equals 2. Is everyone happy with that? Okay. I have no idea what this graph is going to look like. Let's just plot the coordinates in. So, I think it's going to look like this. Are you ready? Oh, okay. It's going to go. I don't know. It can't just look like a quadratic. Okay, it can't. But we know it's got equal roots here at 2, 0. We know it's going to cross at 0, 16. But it cannot be a quadratic. So I've just done these little lumps. Let's check. Okay, so that is incorrect. We've just checked on Desmos. It's like a fat U. So make sure it doesn't touch the axes until 2, but make it really clear it's a bit elongated, okay? Okay, sorry everyone, late recording, just catch up. 3, 0, and this point was 27. Oh, look at me, forgetting my coordinates. 0, 27. Perfect. So, when we're looking at reciprocals, okay, I'm going to draw our x and y. Everyone should know what this first graph looks like. If you do not know what this looks like, just imagine your x and y. You're not plotting points, but just imagining. Okay, if we do -2, -1, 0, 1, 2. Okay, if we do 1 over 0, it is impossible. So, we're going to have an asymptote. Okay, an asymptote is where the graph will never cross. Okay, so asymptote is when y equals 0. No. So, for example, if we had the line e to the power of x, y equals ex, yeah? I know some of us have heard of these before, but just very quickly, if I had this line, it's going to look like this. And it's going to cross here at 1. Okay, you can put this into Desmos and check it. Done my coordinates wrong again. Sorry. Okay, exponentials, which we'll talk about. It's going to cross at 0, 1, but it will never, this blue line will never cross this x-axis. Do we understand? It will never, forever, it will continue, and it will get really, really close to it, but it will never cross it, okay? It's just impossible, because we will never have a negative y value, okay? It will never go up, it will just continue, get as close, forever for infinity.
Seriously, and it won't touch?
And it won't touch, look. An asymptote is where the line will never cross. So for example, it will never cross the x-axis. So this is my asymptote, and I use a dotted line. And my asymptote is where, in this case, y equals 0 for e to the power of x. Okay? 1 over x should look like this. It's right here. Oh, on the call. And then minus 3 over x, okay? What does that mean? We've multiplied 3 by x, so we've actually divided my x coordinates by 3. Now, am I right in saying that 1 over x, that this is a point here? What is this point? 1? Is it? So this point is 1, 1, and this point is 1, 1. And don't forget, minus 1. Oh my. Wait there. This is minus 1, minus 1. Okay? And then, we've got our asymptotes, okay? So it will never, so our asymptotes are actually on the line y equals 0 and x equals 0. And remember, we discussed this yesterday. It will never touch that line for infinity. Okay? So, the next one says y equals minus 3 over x. Okay? Well, if we think we have y equals minus 3 lots of 1 over x. Is everyone happy with that? That is the same as minus 3 lots of x. Now, even though I've put it outside the bracket, this is affecting the x. So we're going to divide all the x coordinates by 3, okay, and minus 1. So now, our new graph we're not shifting it anywhere, okay? So our new graph, if we flip everything, I think is instead of 1, 1, it's going to be minus a third 1. So minus a third 1 is here, like this. Is that right? So our new point is here, this is going to be minus 1, 3, and here we're going to have 1, minus 3. And again, we're going to have our asymptotes on these lines here. Not recorded. Okay, so because we're squaring, if we think, we know the graph of y equals 1 over x, if we're squaring, we're not going to have negative values of y, because whenever we square a number, we're going to get a positive. So our graph is going to look like this. Okay, we're going to have our x and our y. And then this is going to be at 1, 3, and minus 1, 3. Then, if we square it and then minus it as well, oh, look who it is. Najib. Good morning. It's going to be reflected here. Which is going to give me, oh no, it is going to be there, and this is going to be 1 minus 4 and minus 1 minus 4. Okay, and don't forget, it's really crucial, we've got our asymptotes. Okay, now these graphs are drawn absolutely terrible. I'm really bad at drawing reciprocal graphs at the moment. So I will practice this. So, this is the same for the graph y equals 1 over x or y equals 1 over x squared, okay? So the reason why they do not touch the x or the y axes, okay? So first of all, if we let x equals 0, we're going to get 1 over 0. We can never get 1 over 0. We would never do 1 divided by nothing. Okay? So therefore, it will never reach 0. Okay, it goes on forever. Okay, so now, on the same graph, we need to sketch 2 different reciprocals, okay? I am going to use Desmos for this. So they never meet. So when we're sketching, we've got to be really careful with how we sketch them. So we can see here is the sketch. Okay, the red graph is y equals 1 over x, and the blue one is y equals 3x. Okay? 3 over x. Okay, so what I would like you to do is you just have to be able to sketch these, okay? This is going to take a bit of practice and time, but you're going to do, okay, write this down, 1 from question 1 and 1 from question 2 for homework, please. Okay, so points of intersection we've had a look at recently. And when we're looking at points of intersection, it's when the 2 graphs actually equal each other. Okay, so we know that if we were drawing 2 graphs, okay, and in this case, I'm going to sketch this example. So I'm going to draw it a bit bigger, sorry. So here we go. We have, on the same diagram, sketch the curves for the equation y equals x, x minus 3, which I know is a quadratic, x squared and minus 3x, okay? So x equals 0 and x equals 3. So we should be fairly comfortable right now sketching these. So this one is a quadratic. My roots are x equals 0, x equals 3, and my y-intercept is 0. So we should be fairly confident that this is just going to look like this. And I have 3, 0, and this is 0, 0. Perfect. Now my next one is y equals x squared 1 minus x. Okay? Now remember, Kate has been writing this way. X squared is the same as x plus 0 squared, x plus 0 squared, 1 minus x. Okay? So our roots are going to be x equals 0, which I know will then be an equal root, okay? And we have x equals 1 is another root. If I have a look, I've got x times negative x. So I have a negative x cubed, which is going to be a, starting in the top left, this shape. And 0 times 1 means my y-intercept is in fact 0. Okay, so we should be fairly confident now at sketching cubics. So here I know it's going to cross at 1. It's got a double root at 0. Okay, now this may or may not look like how it's supposed to be. So let's just think about this. And then it's going to cross at 1. So I personally think it's going to look like and this is 1, 0, and again this point is 0, 0, okay? So my graph is going to look something like this. I mean, obviously, this one might be a bit moved over because if you think if 1's here and 3 here, the gaps don't make sense. But again, this is a sketch, okay? As long as you label all of the points of intersection on your sketch, you will get full marks, okay? Then it says, find the coordinates of their points of intersection. So I know, by looking at the sketch, that it at least intersects twice, roughly. Okay, from my sketch, I have no idea what the coordinates are because it's a sketch. We're not actually sketching it on graph paper. So what I am going to do is put the two equations equal to each other. So I've got x bracket x minus 3 equals x squared 1 minus x. Now the left-hand side has a factor of x and the right-hand side has a factor of x. Okay? So, can I divide by x? Absolutely. So I'm going to take an x from here and then this is just going to become an x. Okay? So now I'm going to have x minus 3 equals, and I'm going to expand the left-hand side, I'm going to get x minus x squared. Okay? I'm going to move everything to the left-hand side, okay? So then I'm going to get x squared and then minus 3 equals 0. Okay? So that means that x squared equals 3. So x equals the square root of 3 plus or minus. Okay? Now, we also know that they intersect at 0, 0. Okay? So we know that x can also equal 0. X can equal 0 and y can equal 0. Okay, but x, now if we look at the graph, x actually here is a positive. This is a positive root 3, isn't it? So we're going to reject the negative. So x equals root 3. If x equals root 3, y is going to equal, and I can substitute in root 3 into any of these. So I'm going to get 3 times 1 minus root 3, which is 3 minus 3 root 3. Okay, I did do that a little bit fast, but just so you know what I did, all I did was substitute x equals root 3 into this equation, and I just did it in my head, but you can use a calculator. They're not the only points. So our other coordinate is root 3, 3 minus 3 root 3. This is something we've got to really be careful of, okay? This red line actually crosses here. It actually goes like that. Can you see? So that's why we have a minus root 3 as well. So really, we shouldn't be rejecting the minus root 3. We've also got minus root 3 is another coordinate. So y equals, so y is going to equal minus root 3. Y equals minus 3 plus 3 root 3. So that's another coordinate. Minus root 3 and minus 3 plus 3 root 3. Okay? So just double check that. Please be careful when you draw the graph. Do not make that same silly mistake as me. You don't know on this side for a fact which graph goes under the other. So if it does give you a plus or minus, well then you know you've got an extra 2 solutions and your graph is slightly wrong. So positive 3. Oh. So y is going to equal positive. Oh, wow. Right, so x equals minus root 3, y equals 3 plus root 3. There we go. Perfect. Yeah, so please double check that, okay? Don't do the same mistake I did, but it's quite good that I made that mistake because then none of you will ever make it again. So remember, x squared minus 1 is the difference of 2 squares, which is x minus 1 or x plus 1. Or remember, it's when this bracket equals 0. So essentially you're doing x squared minus 1 equals 0. x squared equals 1. So x equals the square root of plus or minus 1. So x equals plus 1 or x equals minus 1. Okay then, so we are looking at transformations of functions. So what we'll have is they'll give us a function and they'll tell us f of x equals x squared. Okay, and then it says sketch f of x. Now we should all know that x squared, the sketch of x squared is going to look like this. And our points of intersection are just 0, 0, and that is it. Now, from GCSE, a lot of us will know that when we're sketching functions and they tell us it doesn't matter what the function is, we always start, our starting function is this graph. Now, f of x plus 2 affects, because it's inside the bracket, it only affects all the values of the x. And what we're going to do is, because it's plus, okay, what we're actually going to do is it affects x, and we're going to do the opposite of what it says. Instead of add 2, we're going to minus 2 from all of the x coordinates. So what that means is actually we're moving in the left direction twice. So our only coordinate we have to go on is 0, 0. So now this would move over to negative. This coordinate here would be negative 2, 0. Now you can see we have a new intersection here. Okay, well, it's nice and easy. If you think this would have been 2 across, so this would have been 4, okay, because 2 squared is 4, and the function is x squared. So this now becomes 0, 4, okay? So all we've done is that this is a translation. If we're adding or subtracting, we're translating, moving left and right, if it's inside the bracket for x, up and down if it's outside the bracket. So, here we go. If the change is inside the bracket, it affects the x-axis. And what do we expect? The same or opposite? Opposite. We always do whatever is inside the bracket, we do opposite of it. If it's outside the bracket, who does it affect? Y. And do we do what we expect, or do we do the opposite? We do what we expect. For example, so is this inside or outside the bracket? Inside. So it affects x, and it's asking us to minus 3 from all the x coordinates. What are we actually going to do? Add 3, because we do the opposite. Okay, and this actually means it moves to the right 3 times. Okay? Then, is this one inside or outside the bracket? Outside. So who does it affect? It affects the y-axis. And what are we going to do with the y? We're going to add 4. We're going to do what it says. And that means our graph moves up 4. The next one, inside or outside the bracket? Who does it affect? It affects x, and it's asked us, this means 5 lots of x, which means 5 times x. Okay, but we do the opposite. Instead of timesing by 5, we're going to divide by 5. So this means the graph actually gets squished, doesn't it? No, squished this way. Okay, so gets smaller. Smaller width. Okay? Now, the last one, inside or outside the bracket? Outside. Who does it affect? Y. And it says it's 2 lots, so we're multiplying by 2. Do we do what it says? We do. We multiply by 2. So this means our graph's actually going to get longer. So it's going to be longer height. It's going to be stretched out, isn't it, vertically? Okay? Sketching transformed graphs. Okay? So here we go. Y equals, wow, I don't know where that went. Here it is. Ooh. Okay, y equals x squared plus 3. Okay? If my f of x equals x squared, what's actually happened is here I've got f of x plus 3. So is it inside or outside the bracket? Outside. Who does it affect? Y. And what are we going to do? We're going to add 3 to all the y coordinates, which actually means our normal graph, is x squared, which I'm just going to draw in blue. Okay, this is our y equals x squared. What we're actually going to do is we're going to add 3, so it's going to move up 3. So now our graph is going to look like this. And our new coordinate is going to be 3, 0, 3. Okay? For the next equation, our f of x actually equals 1 over x. Okay? Because if you think this is something over x. Now, whatever is next to the x means I have, in fact, that's inside the bracket. So that means I've done f of x plus 1, but then I've got 2 lots of it. So I've actually, in fact, multiplied it by 2. So I've got 2 things going on. Okay? So this is 2 lots of f of x plus 1. This will give me 2 over x plus 1. Okay? So, is it inside or... So we've got 2. We've got 1 inside the bracket. So the 1 inside the bracket affects the x, and we're going to minus 1 from all the x coordinates. And then we've got 1 outside the bracket, which affects the y, and we're going to multiply all the y coordinates by 2. Okay? So how I like to do this is I always like to sketch my original graph. And this original graph is 1 over x, which we know looks like this. And we know we have 2 points on our 1 over x, 1, 1, and minus 1, minus 1. And we've got our asymptotes at 0, 0. Everyone should be confident drawing that graph. Now, what we've actually done to the graph is we've multiplied the y coordinates by 2. So our new coordinates, I've got 1, 1 and minus 1, 1. So if I multiply it by 2, my new coordinates for y is going to be minus 2. And on this side here, it's going to be 2. Yeah? And then what I've done is I've taken away 1 from each coordinate. So this is going to be 0, and this is going to be minus 2. Okay? Because this affects, my x plus 1 affects my x coordinate. So I've taken away 1 from each coordinate. 1 minus 1 is 0. Minus 1 is minus 2. My y coordinates, it's on the outside, it's affected y, I need to multiply them by 2. My y coordinate was 1, it's now 2. My y coordinate was minus 1, it's now minus 2. So now when I'm sketching this, I'm going to have 0, 2 as that point. Okay, that was there. And then minus 2 as that point. But what's going to happen now is when I'm sketching, remember, my asymptote is going to change because I've shifted it. My asymptote was before on the line here. This is where my asymptote was. It's now going to be on the line This is my asymptote, and you have to draw it in. Okay, this is now where my asymptote is. It hasn't changed on the x-axis, okay, because I haven't had to move the graph up or down. So I still have an asymptote on y equals 0. So my new graph is going to be this red one. It's going to look like, okay, and then on this side, it's going to look like that, okay? So for these examples, I'm not going to put these into function form because we already know they're factorised for us. We can have a look at the roots. So what this is going to help us with is, on our first graph, I'm going to sketch in blue. Okay, now we should be happy sketching this first part of the graph. We know that it's, I have a root at x equals 0 and x equals -2, and I have no y-intercept. So my graph essentially is going to look like this, okay? And we have 0, 0, and we're going to have -2, 0. We should all be very confident sketching that graph. Now the next part of the graph is the part that we need to think about. Okay, what's happened here, okay, is that it's told us x minus a. So instead of writing x, it's x minus a. So we are actually now going to be drawing the function of f of x minus a, okay? So our f of x was x bracket x plus 2. We're now going to be drawing x minus a because instead of writing x, they've written x minus a. So our new function is f of x minus a because they've substituted that into the first equation. And it says a is greater than 2. Okay, it's greater than 2, not greater than or equal to. It's greater than 2. So that means, let's say a equals 3, for example. It'd be x minus 3. Okay? So that would mean I would have to shift it, because is it inside or outside the bracket? Inside. It affects the x, and it's minus a. We're going to do plus a. So now I'm going to shift it plus a in this direction. So what the graph is going to look like, it's no longer going to cross at 0, 0, because a cannot be 2. If this was 2, then it would move here. Okay, but what the new graph is going to look like is something like this. Okay, this point, because I've added a, is going to be a0. Okay, this point here is going to be minus a plus 2, 0. Because we're not sure, because if a was 3, oh no, minus 2 plus a, sorry. Minus 2 plus a, 0. Because if a was 3, minus 2 plus 3, it was here at minus 2. If we add 3, it's now at 1. Okay? This one before was at 0. If we add a, we're now at a. Now this point here would have been over here, and this is where x equals 0. So when x equals 0, okay, this coordinate is actually, if x is 0, I've got minus a times minus a plus 2, which is going to give me a squared minus 2a, isn't it? If x equals 0, and I multiply this out, I'm going to get minus a bracket minus a plus 2, which is going to give me a squared minus 2a. So this is going to be a squared minus 2a. Okay then, so for the second part of the question, everyone should have been able to do part A. And I'm going to sketch this in blue. So we should all be feeling comfortable sketching y equals x squared minus x minus 4. So that means I've got x equals 0 twice and x equals 4. And it's a positive x cubed, so it's an n. Which means, do we have a double root? Yeah. So, is it going to look like this? Yeah? So our coordinate is 0, 0. And this point here is 4, 0. Okay? Now, so everyone should be really comfortable doing that. If we look at the difference between these two equations, everywhere there's a x, what have they put in? 2x. So this means it's inside the bracket, essentially. So this is f of 2x. Is it inside or outside the bracket? Inside the bracket. Who does it affect? X. It affects x, and this is 2 lots, which means multiplied by 2. We're going to do the opposite, which is divide by 2. So all the x coordinates, we've only got 0, 4, 0. 0, 0, if I divide that by 2, I just get 0, 0. 4, 0, if I divide that by 2, I'm going to get 2, 0. So our graph is actually going to look like, now remember it needs to be shrunk. So even this side needs to be shrinking a little bit. Our graph is going to look like this. And now this point is my 2, 0. This point is still 2, 0. But can we see we've just squashed it? Okay? Okay, we need to sketch the graph y equals x, x plus 2. Now we know that this has a y-intercept at 0, it has a root at 0 and a root at minus 2, and it is a quadratic. So this graph is going to look like this. And my points of intersection are 0, 0, and no, it's not going to look like that, is it? It's a negative 1, so it's actually going to look like this. So our points of intersection are 0, 0 and minus 2, 0. We should all be really confident drawing this beginning graph now. Okay? Then, this is f of x. It's now asking us for minus f of x. Is the minus inside or outside the bracket? Outside. So who does it affect? Y. It tells us by multiplied by negative 1, essentially. That's what it means. So all my y coordinates, I'm going to multiply by negative 1. Does that change the graph? Okay. It does change the graph, but in this one, because all of our our coordinates that we've just put on there are 0. It's hard to tell, isn't it? But if we actually looked at the minimum point here, okay, it's hard to tell when our coordinates of y are 0 because we don't know what's going to happen. But if we looked at this minimum point, for example, okay, so if we complete the square, if we have x squared plus 2x, if I complete the square on that, I'm going to get x plus 1 squared minus 1. This point is, my coordinate is minus 1, which makes sense. This would be minus 1, wouldn't it? Now I need to multiply my y values by minus 1. So this y coordinate, my new y coordinate, is in fact going to be minus 1, 1. So what it actually does, it is a reflection in the x-axis. So now your graph is going to look like this. Okay? So it will always be the case that if it's minus f of x, it's a reflection in the x-axis. If it's f of minus x, it's a reflection in the y-axis. Okay, here we have two more questions. It says test your understanding, so you can give this a go, but I'm going to do them in the background so we can do them together if you want. So very quickly, I'm going to draw my x and y. Okay, now I'm going to sketch y equals x plus 1, x minus 2. So my roots are x equals minus 1 and x equals positive 2. And my y-intercept is 1 times minus 2, which is minus 2. So what this graph is going to look like, I'm going to do this graph in blue, because I just want you to see what this graph looks like in blue. But actually, when you do the exam, you don't have to draw the first graph. But if you don't draw the first graph, how do you know what it looks like when it's translated? So I always draw it, but I draw it in like a lighter colour. So if I draw this in blue, this is going to be, it's going to cross at minus 1. There we go. So this coordinate here is minus 1, 0. This coordinate here is 0, minus 2. And our last coordinate is 2, 0. Okay? The next part of the question says, f of x divided by 3. Is this inside or outside the bracket? Inside the bracket. So who does it affect? X. It tells us to divide by 3, so we're going to do the opposite. Multiply by 3. So for this one, it's minus 1, 0, and I'm multiplying all my x coordinates by 3. So this is going to become minus 3, 0. For the next one, it's 0, minus 2. If I multiply by my x coordinates by 3, I'm still going to get 0, minus 2. So this is going to be the same point on both graphs. Then the last one, I have 2, 0, multiply my x coordinates, I'm going to get 6, 0. So in actual fact, okay, it's going to look like this. That's 3. It's going to cross at the same one. Okay? I've had to, because I drew it too big on the first one. So you can imagine, I'll just put a little line here. So you can imagine, okay, this coordinate is now minus 3, 0. And this coordinate is now 6, 0. It still crosses, actually, I've done this a terrible drawing, really. If you think, it should kind of go a bit more down like that, yeah? Okay? It's absolutely despicable. I'm drawing it again. Right. So I'm just going to draw the blue one a bit smaller this time because I went a bit crazy. Here we go. Okay. So, for the blue one, I know it's going to go minus 1. Here we go. So, my coordinate is minus 1, 0, 0, minus 2, and 2, 0. Okay? So, then for my function is x divided by 3. So it affects the x, which means I'm going to, instead of dividing by 3, I'm doing the opposite, which is times by 3. I have 3 coordinates. My x coordinate is minus 1, 0, and 2. So my new coordinates, I multiply by 3. So instead of minus 1, 0, I'm going to have minus 3, 0. 0 minus 2 is going to be the same, 0 minus 2. And 2, 0 is going to become 6, 0. So if I draw this again, it's still going to cross this point. But this time it's going to cross at 3. And so this point is now this coordinate minus 3, 0. And this point is now this coordinate. And it's still crossing at 0 and minus 2. Basically, it just got fatter, is what's happened. Okay? It's gone fatter. Perfect. So the next one. We have our x and y. Now, sketch the graph of 2 over x plus 1. So I know the graph of 1 over x, okay? 2 over x plus 1, nothing is attached to the x. There's no plus in the denominator. X is not multiplied by anything on the denominator. So this is actually 2 lots of f of x plus 1. That's what this is, okay? Because nothing is actually, x on its own is just x here. If this was 3x plus 1, then this would be 3x plus 1, okay? So that's how I know it's affecting the y. So I know that x plus 1 looks like this, okay? And these are my coordinates 1, 1. Minus 1, minus 1. And this is 1, 1. I know that, and I know I've got asymptotes. We should always know that. Then, what am I going to do? First of all of this is on the outside, isn't it? Okay? So, what I'm going to do is, and just like BIDMAS, multiplication comes first before addition. Because all of this is on the outside, it all affects the y coordinates. And what are we going to do to them? We're going to multiply them by 2 and add 1. Okay? So all of my y coordinates are multiplied by 2 and add 1. So instead of 1, 1, it's going to be 1, 3. My new coordinate is going to be 1, 3. Now, don't forget, my asymptote is here where y equals 0. So if I multiply 0 by 2 and add 1, my new asymptote is going to be when y equals 1. You need to draw that asymptote or you're not going to get full marks. And this asymptote is at 0, 1, okay, when y equals 1. Okay, this asymptote is when y equals 1. Okay, then our other coordinate is going to be minus 1. So it's going to be minus 1 times 2 is minus 1. It's still going to be minus 1, isn't it? Minus 1, minus 1. So now how it's going to look is like this. Now you can see it's never going to cross this asymptote line. And on this side, it's going to look a bit more like that. Okay? So this is how it's going to look. But really, these two should be on the same point still. Is it inside or outside the bracket? Who does it affect? We do the opposite. So what we're actually going to do, minus 1 from x. So on the first coordinate, it's 4, 3. Our x is always that one. So this is now going to become 3, 3. The next one's going to become 0, 0. The next one's going to become 5, negative 4. Perfect. Right. Inside or outside the bracket? Who does it affect? X. And it says times 2, but we're going to do the opposite, which is divide by 2. So we're going to have 2, 3, a half, 0, and 3 minus 4. Okay? Inside or outside the bracket? Who does it affect? And what are we going to do? Multiply by 3. So we're going to get 4, 9, 1, 0, 6 minus 12. Okay? Inside or outside the bracket? Who does it affect? Y. And what are we going to do to all the y coordinates? Minus 1. So 4, 2, 1 minus 1, 6 minus 5.